It's Frank. I'm glad that you're here. Today we're going to talk about cloud services. So if you're familiar with some of the other live streams that I've done recently, where I'm looking at different skills that relate to digital transformation. And today the skill that we're going to look at is called cloud services. What is the cloud and how does the cloud work? So welcome everybody here who's live, and you can feel free to ask questions. I have a screen here on the side where I can see comments from YouTube and Facebook. Or if you're watching this after the fact, which seems to be the majority of the views, if you're watching this after the fact, feel free to comment down below, and I'll do my best to answer any questions you may have or to provide you with resources that you may be looking for. So this is really part of a series of live streams that I wanted to create because I'm finding that there are some foundational skills that people have when it comes to computers that need to be revised. Make sure that you're up to speed. And my goal here is to help you. So you may have come here on your own. You may have been sent here by an instructor that wants you to brush up on some skills. The point here is that we're going to look at different skills that can make you more effective in learning, make you more effective in your career, and just make you more effective in life. So we've done a few already. So we went through and we did file management during the last live stream. So we did a thing on file management. Let me just grab the screen here. So you can see here that we're looking at digital skills here. We're looking at how we can work with digital skills. And so we did file management previously. I'm just going to go in here. So we go and grab this. So there we go. Did file management previously, talked a little bit about that. I'm going to do internet maybe next week, where there'll be predominantly something called DNS and how the internet works. But today we are doing cloud services, and we're going to talk about why these are important, why you want to learn cloud services, what they are, how they fit into an overall infrastructure, how they were developed and fit into an infrastructure. And at the end of the video, I'll give you some resources of where you can go to get even more in-depth knowledge about cloud skills. But let's just pop over here and take a look at cloud services themselves. Basically, understanding and working with cloud computing is an essential skill today. Whether you're using it in business, whether you're using this on your own for your own purposes, it's very important to understand cloud computing because there is a huge demand for people that understand cloud computing. And like many things in the world, there's the demand of being familiar with something. You know, if you were familiar, I have to stop talking when I use my pen because I can't spell and talk at the same time. So you have to be familiar with cloud computing, no matter what your job is. So you might be working in a position where you're doing finance, or you're a position where you're doing data input. You might be at a beginning of your career, or might be near the end. Wherever you are in your career, you need to be familiar with cloud computing because it's generally going to be something you're using in one form or another. Now, as you become familiar and you gain more knowledge, you can, of course, expand your knowledge out to become an expert in cloud computing. You might become expert in one area of cloud computing, for example, a specific application like Salesforce, or you might become familiar with a lot of different aspects of cloud computing depending on your job. We're going to go high level in this particular live stream. We're going to talk about cloud computing and such, but I'll give you the hooks that'll get you started on a longer journey if you wish to take that. So demand is really big. And the reason why demand is so big with cloud computing is because it has been proven to be a very cost-effective mechanism for companies. Effective? Okay. It's horrible spelling. Now I'm just going to embarrass myself on the line because of the cost. So because of the cost of cloud computing, and I'll spell effective later, it's really going to be something that a lot of companies are looking for in terms of ensuring that they can maximize their dollars. This is a big thing where a lot of companies are moving away from capital costs into operational costs. And I'll talk a little bit more about that later when we talk about some of the benefits of the cloud. And the reason why that cost is such an important factor is because we have something, flexibility around the use of resources. And what we can do here is we can not only have the flexibility in terms of scaling our resources as we need them, but it gives us the ability to have what we refer to as elastic resources, which means we can scale them up and we can scale them down on an as-needed basis. We also can do things like a lot of data analysis and management in the cloud. So by having that central repository of where things occur, we can manage the data in there. There's a lot of things around remote work that we can do in there. There's a lot of integration and portability. So the cloud has many, many different things that we need to do. Let's first look at what the cloud is before we start looking at all of the great benefits there. So first, to understand cloud computing, we need to understand that it really represents something that's referred to as the third wave of computing. And in the third wave of computing, it follows off the first wave, which were mainframe systems. And each of these, by the way, had evolution within each wave. So the very first computers that were built were purpose-built, one computer for one purpose. We're talking back in the 1930s and 40s, really. But you could go back further. We're not going to go into, the Babbage engine and such. But anyways, the mainframe, or a single purpose-built system, then they became general purpose, but still very large systems. The second wave would have been desktop and workstation. And I'll talk about those waves in a moment. But cloud computing represents the third wave of computing, which is really an evolution that occurred from the first, which evolved into the second, which was now in the third wave of computing. Let's go back in time a little bit. Let's talk about the basics of what a computer actually is. So when we talk about a computer in general, it's really comprised of three main functions. I sometimes break the compute into CPU as well as memory, but you could break this into chipsets. But at a very high level, computers really compute, hence the clever name of computers. So they'll compute and they'll process information through the circuitry on the board. So inside of a computer is a motherboard. And attached to that motherboard is a chipset. One of the key chips on that chipset is going to be the processor, the central processing unit. And then you'll have memory, which is used for bringing information to and from the processor, and for short-term, near storage. Then we have long-term storage. So, in the old days, we would have the floppy disk. We moved that up to the hard disk, solid state hard drive, whatever the case may be. And then sort of an evolution, and I put network here, but we could think of the network as not just the network. We could think of this as the I/O system. So we could really think of this as being input-output, where we're talking about any type of printing that we do would be an output. Any type of input we receive, like a keyboard, would be an input. But I usually put the network as a significant one because it's the interconnectedness that really allow me to use computers in a more meaningful way. Something we take for granted today is the interconnectivity of computers on this big network. It's an inter-network of computers, or the internet. And like I say, I'll do another live stream where I talk about how the internet works and DNS and all that sort of good stuff. But if we take our systems as having a place to store data, a way to compute with that data, and then a way to share and communicate that data in and out of the system through some sort of I/O, most significantly the network, this will help us understand each of the waves of computation, and it'll help us understand sort of why the cloud is so important and how we can use it. So going back to the mainframe, this is not a computer history course, but it's important to understand context before we get into the cloud. A mainframe system was one monolithic system. It was managed by, a bunch of fellows in lab coats. So we had specialized skill sets in here to go in and manage the system. Sysadmins would go in and they'd have one central repository of compute and storage and connectivity. And the connectivity was to what we refer to as dumb terminals. And the dumb terminal was basically just displaying the results of the compute storage information that was occurring on the mainframe. And it was often done through a time synchronization process. So it just basically spin around to all the terminals. And when you got your allocated time slot, you would be able to input, output to the mainframe. The mainframe would then queue all the jobs it needed to do. It would process those jobs and would give you the output in the terms of command line information. In my day, back when I was working with mainframe computers, I was working with Fortran 77, Wacom Fortran 77 for engineering, and Pascal and COBOL. These were the languages that we would run on these mainframe systems. We would talk to the mainframe through a terminal of some sort, generally located near the mainframe. We could have a terminal that was located at a distance. So if you ever worked in the hospitality industry or the airline industry, there were terminals called part of a system called Sabre, which allowed us to have a terminal in a travel agent office. I'm going pretty far back in time, and we'll get to the cloud because that's really where we're at today. But this is an important concept to understand, because the concept of centralized control over storage, compute, and input-output will come back. In many ways, the cloud has returned to some of the benefits of the mainframe system while eliminating some of the constraints of the mainframe system. We get things like specialized people that can work on one aspect of the centralized system. So I could have a dedicated team, for example, that does nothing but security. So there could be a dedicated security team, and I could have a dedicated user account manager. So we get that centralized control, which is very powerful, but we get distribution of those resources. We'll come to that in a moment. After the mainframe, we created what was called a local area network, or a LAN. And this is also going to be very important when we start looking at cloud services, because the LAN is us controlling an environment or an infrastructure. So every single computer on the LAN would have its own control of its compute and storage and I/O, right? So it would have control of that. And then we would have some computers that were special. So maybe I had a server computer that had a whole bunch of, maybe I had a file sharing server, which shared files. Maybe I had a web server, which served web pages. Maybe I had a database server, which served data files, or it hosted a relational database management system, and I could input, output, and talk to it. But what was really important here, and this is a very important thing, is that if I was an administrator or a sysadmin, I would have to administer this entire infrastructure and make sure that it was all working. I'd be in charge of the printers, the various servers, the various computers. The nice thing, though, is if one of these computers went out, if it broke, I wouldn't have to worry about it taking down the entire infrastructure. That being said, I would often have to do things like, if I had a critical server, I might have to go into that critical server. Let me just grab my critical server here. I might have to take this critical server, and I might have to make a secondary copy of that critical server, because I needed redundancy. I needed to make sure that I wouldn't have a single point of failure. So every time I had a database server, one wasn't enough. I had to have two. So if one went down, the other was still there. A file server, a storage server, whatever I might have, you'd have to create redundancy. If I had only one printer, I might have to go in and I might have to create multiple printers. So you could see that this all of a sudden became very cumbersome to manage as it scaled quite large. And I spent a lot of time training and teaching people how to manage local area networks. This was a big thing for many years. The first, you don't need my brief history either, but the first networks that I worked on was by a company called Novell Networks. And then I moved up to Windows networks and all sorts of different operating systems, Apple networks for a little bit. But the point here is that you have this local area network, and it required a lot of management. So what we would end up what we wound up doing in this case here is we might have multiple sysadmins. As the organization grew, I'd have to hire somebody that was a specialist in databases, a DBA. I'd have to hire somebody that was a specialist in file management, or file server manager. I'd have a Windows admin. I'd have to hire somebody that was a network admin. Then I'd have to hire two more of each, because I'd have to cover off for vacation. So you can see where this becomes quite expensive as you start building a large local area network. So one of the solutions of that was to create a data center. So what we would do when we created a data center is we create one sort of repository, usually, somewhere down in the basement. We would create a repository of different file servers that had the compute layer. So we'd have these file servers in there. Let me grab a pen that you can see here. So we'd have, the CPU, the compute would be in here. And we call it, a lot of times you can hear the term blade servers. So you'd have the CPU computers in there, and then you'd have storage in there as well. So a lot of times you'd have some sort of storage array. I know that I've worked on EMC, I worked on HP arrays, where we'd have multiple storage boxes, each loaded with a bunch of storage. But what do we have to do here? You guessed it. If I want to make sure my data center is safe, I have to take everything in here and I will have to duplicate it so that if one rack goes down or if a certain network segment goes down, if any of that happens, I'll just grab that part there, but you get the idea. So it'd be the whole thing here. I would have to duplicate the entire server infrastructure, right? This entire server infrastructure, I would have to duplicate that in my environment so that if one storage box went down, I wouldn't lose all of my storage. So we'd have to synchronize everything together. And to get even more in depth with this, I'd often have to create a co-locate. So I'd have to have a complete other location where I had two data centers that were co-located with each other. So now you see I'm buying a lot of boxes. I'm buying a lot of blade servers. I'm buying a lot of storage arrays. When I used to build, and I feel like I'm giving a biography here, but you get the idea. So I used to go in and build storage arrays, and these are called storage area networks. We're a dedicated network for storage. This is kind of really, I'll do this briefly. So I'd have dedicated networks just for storage, and then those storage arrays would be duplicated within an environment and co-located to another environment. So if any catastrophe happened, fire, flood, any type of problem, I could switch over to a co-locate. And just to give you some idea, a single box, I remember purchasing one single box that held 12 terabytes worth of data, and that was about $40,000. And then the drives that went in there were about $500 each back then, and we had to have two of them, and then we had to have a fiber switch that connected them together. And I'll do another live stream on networking where I talk about converged networking and unified networking, but that's beyond the scope of this cloud one. What I want to convey here, though, is that we migrated from mainframe all the way to local area networks, all the way to data centers that we controlled. Now, the thing is, all our clients for the data center would be different devices. So I'd have different devices in my, that could connect up to my data center. They would connect up through a network. And that network sometimes would be maybe we'd go through the internet to get back to my data center if I wanted remote working. But a lot of times it was, a desktop in my accounting department would connect to the data center. And that system itself did have the ability to have its own storage and its own compute. But I didn't really want to do that. I wanted all my compute and storage to occur at the data center. And I really just wanted to have this computer connect up to that data center. And then, all my important files and everything were saved centrally. So it's not like if this computer went down that I would lose some important accounting data that might be in there. So I hope that makes sense. And if you're here, I'm not sure how many people are watching. It never tells me. I'm getting used to the live streaming stuff. So if you are watching, feel free to comment and ask any questions as we go along. I'll try to glance over whenever I can. Okay, so you can see that the data center, and we could connect multiple different devices in there as well. So we could connect in, tablets, we could connect in phones. In fact, we'd even have a system to manage the phones, mobile device management. So that would be our data center. So you can see that the local area network evolved. It became a data center in there. Let me just scroll out a little bit. And then what we did is we enhanced the data center by creating what we call a virtualized data center. And this is using something called virtual machines, where what I would do is I would take a portion of my compute here. Let me just grab a different colored pen here. So I would take a portion of my compute and I would share that and create a virtual machine. So now what would happen is that I would have these computers down here, and they could be tablets, computers, whatever they are, and they would have their own storage and such. But instead of them running a operating system of their own, which they would run their own operating system, but what I would do is they would also run a virtual machine. So now what I could do is I could have centralized control within my virtual data center. I could have very specifically configured virtual machines that I then could run on these systems that were in my environment. This is very cool because I could have different applications and security on here. This could be somebody who works for me. This could be an employee's home computer, and their home computer could have whatever on it. Could have all the games on there, could have personal family stuff on there, no problem. And all I would do is I would give them a pathway. And again, a lot of times this would be through the internet. So I would give them a pathway through the network to connect to the data center, and I would allocate them a virtual machine, and they would run that virtual machine without having to worry about antivirus and all the things that I've configured on the virtual machine. They could run the application. Now, there's more to virtualization than this brief overview. If you are interested, I'll put a link in the description below. I actually have some videos here on the channel on virtualization. I also have a Skillshare course on virtualization, and you can check that out if you're a member of Skillshare. I'll put the links below. Okay, so obviously one of the big things that came out in the world was the internet. And the big thing that happened with this interconnected network is we got into money. So e-commerce, right? So we wound up with e-commerce as being a huge driver for the growth of the internet. And again, back in the day when we had bulletin board services and we just dialed in and communicated, a lot of the internet was a social experiment, or not really experiment, a social experience where we just communicated, we helped each other with programming, we would play games online, all that sort of good stuff. But it wasn't very long before the money came into it and we wound up with the first wave of e-commerce platforms, many of which disappeared, but many of which survived. There's actually an interesting, well, I won't go into the statistics or the history of the internet, but briefly, there was an interesting statistic I once read that even though the internet bubble burst in the late 90s, early 2000s, the projections for the growth of the internet have actually exceeded what was predicted at that time. Anyways, so we have e-commerce. Why do we care about e-commerce? That's somebody else's network. It is. It's somebody else's really, really big network. So you would have a company, most notably someone like Amazon.com. And Amazon.com wanted to grow. They wanted to become a really big commerce company, e-com company. And last I checked, they have been. They're huge, right? So they built tons and tons and tons of infrastructure to support their business. And they hired lots and lots and lots of experts that knew how to run very, very specific parts of that business. They hired web developers, they hired storage administrators, they hired sys administrators, they hired security experts, compliance experts, networking experts, everybody that's necessary to run a infrastructure. They hired many of these people, and they were all able to really keep an eye on the entire infrastructure all the time. And in fact, they're large companies today, right? And what ended up happening is they wound up having more capacity than they needed. And some bright bulb, I don't know at what company or when they did it, decided, if we have this extra storage, why don't we allow people that aren't part of our company to come in to the storage here, and maybe we will allow them to come in. So as an individual or a small company, maybe we'll allow them to come in through the internet. So they'll come in through the internet and they can use some of the storage that we're not using. And a lot of system administrators are like, this is great, because now I don't have to buy a second co-locate for my storage. What I'll do instead is I will back up all of my data to the Amazon cloud, Amazon Web Services, and I will store it there. And if I ever need it, because I have a catastrophe, I will then be able to build up my environment and retrieve it from the cloud services, from Amazon Web Services. And this became a great way to have off-site storage that you could then put a lot of your data onto without having to worry about building up and maintaining your own storage area network. And if you only had a bit to store up there, you could store a bit up there. I use a number of different storage services myself. You may be familiar with some of them, and I'll talk about those in a moment too. Okay, so what ended up happening is not only did they build this massive infrastructure, but this massive infrastructure was all across the planet. So you could have a data center in Western US, you could have a data center in Calgary, Alberta, you could have a data center in New York, you could have a data center in London, Germany, everywhere around the planet, you could build these massive data centers. And when I say you, I'm talking about Amazon, Microsoft, Google, IBM, Dropbox, whoever the companies are that are providing these services, they build these massive data centers and they disperse them geographically. So now I'm not only protected because of the redundancy that's provided to me, I can put my extra files into a cloud service. Somebody who's an expert in storage can manage them. I can retrieve them when I need them, and they can be distributed across the globe. So this became something very powerful that was very attractive. And we're just talking storage at this point for anybody around the world that wanted to store their files safely. In fact, I could store files in a location that was closer to the users that would consume those files. So I could be in Western United States. I could be developing programming, different programs and such. I could submit my code at the end of the day. It could be transferred to a data center, maybe in Japan, where somebody could pick up the code, do the testing on the code. Then it could be saved and somebody in England could look at maybe, the finance of the code or approve it or whatever the case may be. But I can, as the world spins, my data can follow it. And that's a very powerful thing to do. We kind of take this for granted nowadays, but you can see we've come a long ways from just having one mainframe computer located in the basement of a research facility to now the idea that we have massive data centers all over the world, and I can get a little piece of that, in this case, just for storage. But things grew from there. So what happened is, I'm moving the cloud. So let's zoom out a little bit here and move over. And what happened is this became the birth of the cloud. So this became where all of a sudden, these companies not only allowed me to store my files there, but they said, you know what? If you want to run a web server, you can allocate resources and you could run a web server. And you may be familiar with a lot of companies that offer this service. So things like Squarespace, things like Wix, things like GoDaddy. And I can mention all three because none of them are sponsoring this video. But the idea is that, you have web services. You don't have to install a server in your basement. You do not have to, configure that server, connect it to the internet. You just have to go online through the internet, use your computer, go online through the internet and borrow a little bit of their infrastructure. And this became extremely interesting to people building web services. I mentioned earlier that it became very interesting to people that wanted to do storage, right? So you could do storage on here as well. Excuse the handwriting, that's actually pretty horrible. But you could do storage on there. And then we started getting a lot of different things that we could do on the cloud. In fact, there are things that you could do on the cloud that would be very, very, very expensive to set up on your own. And what I mean by that is there's sort of this minimum expense that you have to go through in order to set up a web server. You have to buy the hardware, you have to buy the internet connection, there's a lot of things you have to buy, right? You might have to buy software. But instead of building a massive website in your basement, if you only have like 5 people that your website is serving, imagine if you could just start off with a little tiny website. And that website gets a little bit bigger. So you could make it a little bit bigger, and it gets bigger and it gets bigger. But as it gets bigger, you will pay more to the cloud service, but that's only as it expands. Well, this gave people a lot of really good ideas, because in the old days, if you were building a software company, right, you would have to put a lot of money into developing the software, and then you could bring it to market and hope that you sold enough of the software to cover the costs and make a lot of profit. And if you didn't, that was a problem. And if you did, that was great. But the biggest challenge there was that you had to make that initial investment. A lot of times that's where a lot of venture capital came in, a lot of investors came in. But if you couldn't get an investor or venture capital, you really had to scramble. And every time you got more customers, you had to scramble to grow your infrastructure. This became super evident when social media networks came out. If I wanted to start a company like Instagram, Instagram has millions and millions and millions of users, but it started with one user. And then, probably two. But the idea is that, because it's a network, but the idea behind any social network is that you could start one and it would be viable with even a few thousand users. And if it doubles, you just double your cloud purchase. And if it triples, quadruples, you just keep buying more cloud services to support that application. Well, this was a game changer, because what this allowed us to do is it allowed a small company with very few employees to basically have access to $1 billion infrastructure, but just a portion of it. And as they needed more, they could buy more. And probably the most classic example of that is Amazon Web Services, right? There's a lot of companies that use AWS or Amazon Web Services in order to run their applications and to run their business. They're not the only game in town, though. The one that I use a little bit more because I'm more Microsofty is Microsoft Azure. So if you have Microsoft Azure, that's a Microsoft solution, multiple billions and billions of dollars worth of infrastructure, and you can just rent a little piece of that and grow and shrink as you need to based upon your own consumption. And that's the essence of the cloud. So that's very, very important for you to understand, right? So when we take a look at different types of cloud services that we have, there's different services that are available on the cloud. So you may have heard of SaaS or PaaS or IaaS. These stand for software as a service. So instead of going out and buying a piece of software and installing it on your computer, what you do is you buy software as a service in the cloud. So the software runs in the cloud and you just connect up through the internet to that software and you can run it. This is very handy. So for example, one of the famous software as a service is a company called Salesforce. Well, if you're selling something, no matter what it is, you probably want to be in front of your customers. And chances are your customers are going to be spread out across a city or across a state, province, or even the world. And you want your salespeople to go to the customer. That immediately makes your salesperson a mobile person. They're mobile. Now imagine if they have a device that's connected to the internet. And imagine if that device connected to the internet is connected to a cloud service that's running Salesforce, and they put in an order for the customer. Well, that order immediately hits your warehouse, which means that the order can be processed and shipped even sometimes before the salesperson leaves the place where your customer is. That just increases customer service. Plus, you could have a website that captures interested customers, so you can see that the whole ecosystem is built for you. You configure it to your specific business and your needs, but you can run that software as a service. I use some mind managing software where I can go in and I can run it on my computer, but then it synchronizes with my with the cloud, and then I can access it through my phone, my tablet, whatever device I may have. This is an extremely common thing to use. Most of the apps that you use on your iPhone or your Android phone actually are web apps. They connect to a source that's in the cloud, and then you can send information to and from the cloud. This also, by the way, is an area where sometimes people be like, wait a second, is this a dangerous thing? Yeah, well, we'll talk about some of the cautions of the cloud in a moment. But that's software as a service. Now, I guess I would say before software as a service, I would also say sort of the very beginning of the cloud was really storage, which was storage. So don't get confused. SaaS does stand for software as a service, but storage in the cloud is a common thing. You may be familiar with things like iCloud from Apple, things like OneDrive from Microsoft, and so these are file servers in the cloud. So you can save your photos, you can save your documents, you can save all that stuff into the cloud, and you can even go in and configure them. I personally, they're not sponsoring this video, but I use a company for myself for my storage called sync.com. Now I do have Macs, so I actually also use iCloud, OneDrive, but my main storage solution in the cloud is sync.com. And for me, the reason I use sync.com is because I'm on a plan that has unlimited storage, and I have terabytes and terabytes of storage, so I can store it all up there. And also it's encrypted end to end and at rest. So I do have a video here on the channel, and I have to post a lot of stuff in the comments down below. But I have videos on sync.com, and I have videos on end-to-end encryption and ensuring that you have encryption both in transit and at rest. But anyways, the idea is that there's lots of different companies that offer storage. There are many companies that offer software. Another good example besides Salesforce would be Quicken by Intuit. They are an accounting package that you can have in the cloud. So if you have multiple offices or branches, everybody can work on the same accounting system, and it's all stored in one central location by Intuit. They have it in the cloud there. Now, the one that's kind of confusing for a lot of people sometimes is PaaS, which stands for Platform as a Service. So imagine that you're a software developer, and imagine that you need to create an application for a customer. First of all, I've already discussed, your customers could be all over the world. I've already spoken about the idea that, you don't necessarily want to send out software to all your customers. If you have 1,000 customers and you have 4 versions of your software, you have to have a pretty big support staff to support everything. So if you want to create software, you're probably going to create software as a service, or a lot of times you might be creating some sort of web-based portal for your customers to come in and interact with your company, like an e-com solution, or it could be even private. It could be your own private application where you only allow your employees to come in, and that could be things like a maintenance or an inventory application or a data application. Well, what Platform as a Service offers is it offers you the building blocks that you can then use to build your own solution. So for example, you might have a database, and rather than having to go get a server, install an operating system, install database software, install the database, configure the security, and then have it available, which you can certainly do. But instead of doing that, you just say, give me a database, you have an endpoint, and then you can have applications that connect to that database as Platform as a Service and put data in and out of the database. And again, I have a lot of videos. I've started to get a lot of videos on this channel, but I do have videos on how to run SQL Server, which is the Microsoft Relational Database Management System, how to run Microsoft SQL Server in the cloud. So you can check those out. It's super handy. So a lot of times if I have a student that wants to understand how to work with TSQL, I'll just say, go and put a database in the cloud, throw a little sample database on there, and then practice querying it. And then when you're done, just delete it, right? And if you're interested, comment down below. I can also make videos on how you can get a lot of this cloud services for free for doing just that sort of thing. So that's Platform as a Service. Then what we have is Infrastructure as a Service. Now, this is if maybe you have all of the infrastructure resources, and maybe, the people, the staff, everybody that you need in order to run it. And what you really want to do is something called lift and shift. So you want to lift it out of your basement, out of your data center, and you want to shift it into the cloud. But you've got maybe customizations on the servers. You've installed the operating system in a special way. You've configured the databases in a way that requires you to have operating system connectivity. You can't just spin up a generic database with some configuration options. You need to spin up a server that has an operating system, that has a database, because there's a lot of customization you did there. And you can do a lift and shift or a migration, or you can build infrastructure in the cloud. But here, you don't have to go and buy the hardware. If you want a new server, click, you have a new server. As opposed to the old way, what are the specs I need? What is my growth projection? How long do I think it'll take to arrive? When do I need it by? Go and get a purchase order, get the purchase order approved, find 3 vendors, choose the appropriate vendor based on a cost-value comparison. You can see getting a new server was actually a big job in the old days. Nowadays, getting a server on the cloud is getting approval to spend the money and then clicking a button and then setting it up so that as the server grows, it grows in power as well. Nobody's going to complain if you have a website that's an e-com website and it's very low powered and you're spending $40 a month on that e-com platform, and all of a sudden you bring in $10,000 worth of revenue. And then you say, well, I want to make sure that server's faster. So you double the size. It's now $80 a month and you bring in $20,000. You can see it all of a sudden becomes a very powerful thing to do, right? So that would be software as a service, platform as a service, and infrastructure as a service. Those are cloud terms that you kind of need to know. So we've gone through, and the cloud's not always, I should point this out as well. The other thing that you can do on the cloud that's kind of cool, and once again, I have a lot of videos on this, is you can actually run a virtual machine in the cloud environment. So you could have the cloud environment, you could actually spin up a virtual machine and then put that onto the desktop of one of your employees. So now you can control the virtual machine in the cloud. And when I say you could be both the creator and the consumer, or it could be your your IT department creates it and you consume it, whatever the case, or you might be the IT department. But it's important to understand, if you're the user, that if you're running a cloud PC, what do you need? Internet connectivity. You need to bring the keyboard, the video, and the mouse here. And I've got a number of videos here on the channel on running cloud-based PCs. I use it a lot of times, or I should say my students use it a lot of times. I use it as well when I have a Mac. So if I have a Mac and I need to run a PC, I can either create a virtual machine on the Mac. I use Parallels as my solution there, or I could run a virtual machine in the cloud and just connect up to it using my Mac. I use that a lot of time for testing or temporary. I need a computer for the afternoon. So I'm on my Mac and I need to have a Windows PC. I'm going to do 4 hours worth of learning or tutorials or whatever on it, or demonstrations, or I need to run Excel native because it has a lot of functions that are PC specific. I can just spin up a machine on the cloud. I can work with it. And then when I'm done, I can just delete it and stop paying for it. So instead of buying a computer for $1,500, I can rent one for 4 hours it can be super cheap. It could be like less than 10 cents an hour, or it could be hundreds of dollars an hour, depending on the power. The big key with the cloud is make sure you don't over specify. Anyways, I do have a couple of videos of why you should and why you shouldn't use a cloud. There's different scenarios. I always get the comment, what about video gaming? Well, Google did have this thing called Stadia for a while. That's now gone. But the idea is that gaming is still something you probably want to do local, but this is not about that. This is about you understanding the value proposition that the cloud brings to your organization. Understanding the difference between software. You're running software in the cloud, you're putting storage in the cloud, you're using the cloud to create your programs, or you're putting your entire infrastructure in the cloud. Now, if you want to learn more about cloud services, there's sort of through 4 big players that I do most of my cloud stuff with. So my big one is Microsoft Azure. So I use Microsoft Azure for a lot of services. They have obviously platform infrastructure, databases, software as a service. Their software as a service, you may have heard of it. It's called Microsoft 365. That you can run that directly through a web browser. So they have that. Then we have AWS. That's another big one that work with all the time. Amazon Web Services. They're very similar because they compete with each other, but Azure has some things that AWS does not. AWS has some things that Azure does not. Then there's also Google Cloud. So Google Cloud has a lot of options in there as well in terms of building infrastructure and storage. And then you have IBM. And IBM, they have some really cool stuff around AI. And I'm going to talk about that in about 2 seconds just before I wrap up. I'm going to try to keep this to about an hour. So I don't know if nobody's made a comment here, or at least I'm not seeing any comments. So forgive me if I'm not seeing them. And if you're watching this later, again, comment down below. By the way, now would be a good time for me to mention, now that we're about almost an hour into it, if this has been helpful, if this was interesting, hitting the like button can really help the channel. So go ahead and give that like a like if you'd be so kind. So these are 4 big major players in the cloud space. And they usually have general services. So they have services around many different things: databases, virtual machines, compute, data orchestration and engineering, artificial intelligence, lots and lots of stuff in there. Then we have other players like, I already mentioned sync.com. And they're, specifically for storage. And I will put a link down below, because if you are interested, if you need unlimited storage, I can get you, they did sponsor a previous video, and I have a discount code that I'll make sure I'll put the link down below so you can get a discount. Sync.com, you may have heard of Dropbox. They've been around for many, many years as well. You have things like, iCloud. That's basically, if you're a Mac user, you have an Apple account, iCloud keeps all your photos synchronized from your phone to your iPad to your computer. Well, how is it doing that? Through the cloud. So everything's going from here. So basically what it is, you take your phone, you take a photo, goes up to iCloud, and then your tablet and your MacBook are able to get it. And you can install iCloud on a Windows machine as well. iCloud, and then, I would say, Azure is Microsoft's infrastructure. So I would say that you also have things like OneDrive, but OneDrive really is part of Microsoft 365, which is really on Azure. It all lives on top of Azure. The big players, the ones I use the most is Azure and AWS. I'm doing a bit with Google right now. I've done stuff with IBM. I really like them as well. And let me know in the comments down below. If you'd like, I can show you how to get Azure, AWS, Google, and IBM for free. A lot of services, not everything. Obviously, they're not going to let you run your multi-billion-dollar e-com site on there for free, but they'll let you run it on there, just not for free. But you can do a lot for learning. The other thing that I really recommend if you want to sort of enhance your career and get a deeper understanding and reinforce some of the concepts that we talked about here is Microsoft actually has a website. And, let me change the thickness of that pen there. So they have a website called learn.microsoft.com. And that website has some courses on there that you can take for free. And they have one on Azure Basics. So it's called the AZ900 course, and that's Azure Basics. And that'll teach you, there's 4 modules. It takes about 4 or 5 hours to do. And that'll give you the basics of one cloud service. And everything that I've done here today will set you up to really understand that course. And a lot of times you can go and write that certification. It's a great way to sort of show the world that you understand something about the cloud. AWS has certifications, Google and IBM as well. But that one there at learn.microsoft is a really well done course. You can just go off, you can get it. And I'll make some courses as well here. I'm in the process of building some courses. You can visit me at summittechacademy.com. But anyways, so we have all of these wonderful cloud things. And you can see that that understanding and knowing a little bit about the cloud is going to help you become more digitally literate. And that's a very important thing no matter what you're doing. So if you're an accountant and you have to use the internet to connect to your accounting software, you know that you're using the cloud. And if you know that you're using the cloud to connect to your software, then you can also have your storage on the cloud and you can share things with others globally as needed. So understanding the foundations of the cloud, as we've talked about here today, will serve you well. It's a very good skill to have. If you'd like to learn more skills, I'm here for you. So first of all, I'm going to go through and do more digital transformation live streams. I'm going to try to do one a week. So stay tuned for those. Like and subscribe if you want to make sure that and hit the bell notification, and that'll make sure it informs you of any upcoming live streams. And that's for digital transformation, digital skills. I'm going to do some live streams on that. Plus, I have the channel. You can see regular videos here on the channel where I talk about different topics in technology, and specifically a lot around learning in technology, or how we can use technology to leverage our ability to accomplish more, to learn better, to teach better, and to basically do things. So your next step, so I bet you didn't think you'd have a live stream with homework. Your next step is to look at the learn.microsoft.com AZ900 course, and to go and look at some of the things that you use on your computer on a regular basis and say, is it a cloud thing that I'm using? Am I using the cloud when I'm using this software? Oh, even if it's a hexagon. Now I'm thinking about Dungeons and Dragons. Anyways, so am I using the cloud? And if you are using the cloud, are you using software as a service? Chances are that's what you're using. And then you might say, well, what would be an example of platform as a service or infrastructure as a service? And comment down below if you want me to go and do some demos of Azure, AWS, Google, and IBM Cloud. I do have a fair amount on Azure here on the channel. You can see me run some demos where I create a database or I create a SQL server, and that will give you an idea of how I'm actually using the cloud. So that will give you that opportunity as well. Okay, everybody. So thank you very much for watching. Even if you watched live, I apologize. If there's anybody here live, I hope that, somebody did get this. Awesome. So there is somebody from LinkedIn that said hello. So I'll say hello. If you're watching this after the fact, please comment down below. I'll be reading those comments and finding ways that I can help you transform your knowledge base to become more digitally aware without necessarily becoming a technical person, but knowing how technology works so that you're better positioned for your career and for life in a world that's digital. Thank you so much for watching, and we will talk to you guys later and in the next live stream or in the next video. Take care. Bye, everybody.